Hey team, it's John. You are on the JRB tree climbing channel and you're on the playlist, the JRB Ascender Hitch. It was just a couple of weeks ago when I introduced a friction hitch that I devised and have been climbing on in the interest of finding out if that hitch had been previously published. And to date, we're not aware that it has, so we're going to continue to refer to it as the JRB Ascender Hitch. And we're going to have some discussion. My purpose for this video is threefold. First, I want to respond to particular feedback and questions I've got since I released the first video. Second, I want to have a discussion about any failure modes in the friction hitch. And third, I want to talk about the comment I made in the initial video about how it's tunable, any variations, and that is intertwined with the failure mode conversation. So please make sure you watch that video first. I can't repeat everything that I said in that video, but a real quick recap. The friction hitch, quite obviously, holds well. It releases well, it's non-jamming, but it's got a few unique features. The first unique feature, and that's why I call it the Ascender Hitch, is that it's got an optional handle in the form of a carabiner I put in this fashion, which allows during climbing for the climber to put his or her hand on the carabiner, and when load is transferred from the friction hitch to the feet, we can slide this up much like we would a hand ascender in a non-slack climbing system with 2 points of attachment on the rope, one for the bridge and one for the feet. So that is really quite a nice feature. And the other feature I needed was to be able to operate that friction hitch with 2 points of load. So here where my left fingers are, my left hip would attach, and my right fingers are, my right hip would attach. I call this bridge mode because this becomes a replacement for the bridge on my climbing harness or saddle. And I think more appropriately it's called a duplex mode, but I do prefer bridge mode because this becomes my bridge and I can operate it that way. Okay, so just some points on terminology. I had referred to the carabiner as a toggle. I think more accurately it's actually a handle, as its removal doesn't change the integrity of the hitch in any way. And in terms of the geometry, let's get these terms because we're going to talk about variants, so let's make sure we know what we're talking about. We're going to refer to this as the 4-1-3 variant. It has 4 coils on the top. That number could vary. And in that stage of tying it, where I called it binding the helix, we took that descending line and we crossed over 1 strand in the upper helix. And that's the 1. So 4, 1. And in the bottom stage, we can see framed out by this bite that drops down around the back. I called that the drop bite. But we can see 3 horizontal segments of rope visibly framed out. Now 2 of them came from the initial coil and 1 of them came from the line as we finished the hitch. But and there's multiple ways to get that number to a larger number, but I'm not really interested in all of them. So for now, we're just going to call this the 4-1-3 variant. And I'm going to tie one and show you how we can vary that and respond to different failure modes or different features. When I introduced the video, I introduced it and said I don't recommend it for rappel, and then I went and executed a short rappel. I'm going to reiterate, use of a friction hitch for rappel is a kind of an advanced move. You need the right ropes. For example, this is a 12mm rope, and this is 8.5-ish millimeter accessory cord. This is Yale B-line, extremely heat resistant. This is the kind of stuff that arborists use and would be necessary. But for the recreational climber, I generally recommend the use of a friction device, even if it's just a Munter friction hitch or a figure 8, and make sure that the friction hitches are just along for the ride on the rappel. I also require use of a loop at the bottom. All right, so the friction hitch is not tieable in the bite. We need to use a length of cord to fashion it and then close the bottom using a bend. All I'm going to require is that you use a secure bend and one that is appropriate for your application. I'm a fan of the hunter's bend. Other climbers prefer to use the double fisherman's bend, triple fisherman's bend, the sliding variants thereof. We get the figure 8 bend, we get the Zeppelin bend. There's plenty of different bends we could use here. Let's just leave that conversation at you need to close it using a secure bend, and that will create the JRB Ascender Hitch assembly. But let's let this discussion focus on the frictional part of the assembly alone. And the last question I got was, what diameter cord and relative to the rope do I recommend? And like most friction hitches, the generally recommended ratio of 60 to 80%, let's just take that as my recommendation. We can operate outside of that zone, and I will explore some of that in this video, but let me just make that the general recommendation. 60 to 80%, whereby your cord is smaller than your rope. Let's show you some particular combinations. I'm not going to be overly verbose here, just going to flash them and move on. But this is 4mm cord on 11.4mm rope, and this holds great. I wouldn't climb on this, of course, but I've tested it with my body weight. The only observation I have, when you get to these smaller diameters, it's a little bit more difficult to move it, but depending on your application, it would work. Also on this line, getting closer to a standard ratio, I've got 6mm PMI accessory cord, this time with a handle, 6mm on 11.4. So we're close to 50%, and that works great. Let's keep going. Here I've got, by the way, that was closed with a Zeppelin bend. Here I have, and closed with a sliding triple fisherman's bend, I've got 5mm Sterling accessory cord on a 10.1 or 10.2mm Maxim rope. This holds great at about a 50% ratio. Here I've got Blue Water Titan 5.5mm accessory cord. Kind of stiff stuff, very, very strong, but a little bit stiff. Just tied this. And I'm intentionally got it a little bit loose. And in that, I'd like to demonstrate one of the potential failure modes or things that we need to make sure that every climber addresses, and that's how to set the hitch properly. So because it wasn't set properly, I'm able to slide that up and down. Get you. See that? Okay, so how would I set the hitch so that doesn't happen? Well, what I do is I locate the descending line out of the top of the helix, and I draw pressure on that until it binds. That's how we do it. That's how we jam and unjam the hitch. Now, if I get it a little too jammed up, I want to put slack back in it, simply shove a little slack in it, and now I can get it to the point where it doesn't hold as well. Like most friction hitches, you need to have, you need to break in your cords just a little bit till the fibers start to break down and bind. And so I encourage that you do that safely on the climb when commissioning new combinations of cords and hitches. Also on this rope, I've got a 7mm, actually this is 8mm Sterling accessory cord on that same 10mm rope, and that holds great. Let's keep going. This is Sterling Super Static 2, and this is PMI accessory cord in 7mm. That holds great. And this combination is very popular in climbing circles I frequent. This combination is Sterling 6mm TRC, and that's the cord on 8mm Sterling Oplux rope. And I've tied this a few times. This is well broken in piece of cord here. And much like the Michoacan friction hitch, which I also use this combination, when I tested this combination, and especially when the rope was wet, I found on the Michoacan I needed an extra turn in its helix to get it hold properly. And I found the same thing here. So this is the first variant you're going to see today. This is a 5-1-3 variant, whereby, again, in testing that combination and in wet, damp conditions, I determined it didn't hold adequately, had a little minor slipping. I added a 5th turn on that upper coil, so a 5-1-3 variant. And that's what it took. All right, so let's let's come across, and what I'm going to do next is I'm going to tie this friction hitch and show you start to finish how we tie it, and I'll explore an important variant. So we start with a length of rope. You'll have to get that combination roughly right for the diameter of your rope and cord. I usually start with something about my height, and I can always trim off the ends if I need to. And I will be tying this in the Z chirality. So the coils, as I overlay it on the rope and make my first 2 coils, and exaggerating that angle, if I overlaid the letter Z, that's the Z chirality. And Z, or right-handed chirality, it will actually make a left-handed ascender. So when I'm done with this product, it will operate like all the other ones I showed you, so that it's ideal for use with my left hand. Of course, you could tie everything in the opposite chirality, the mirror image, and then you'd be making an ascender for your right hand. I will only explore the one. So I've made 2 coils in an upward fashion in the Z chirality, and I drop the working end down in front of the standing end, around the back, and with that end down through. So let's pause here for just a minute. This nugget, I've been calling it a walnut. I don't really know what this is, but this is actually a friction hitch. If this is published, please tell me the name of this. But this entity here is a friction hitch. And in that light, this entire JRB ascender hitch is kind of like the marriage of 2 friction hitches bound by that link segment that we're going to create. But if you were to just stop here and load, draw it tight, load this side, it absorbs a load. We've got a little miniature friction hitch here. I'm not saying I'd climb on it necessarily, but that constitutes the bottom stage. And we may vary that, but let's start with that as the bottom stage. So when I pass this rope around down through these 2 strands and it lays across the back, I'm now going to start again using that working end to create the upper coil. And it's important, this would be a failure mode, tying it improperly. This is a place where folks might not know which way to go, but remember you started with the Z chirality going from left to right in an upward fashion. We're going to continue that with 1, 2, 3, 4 coils, and then we bind the helix. So this is where the 1 comes from. I am going to bind it across 1 strand, and then creating my link segment here, I am going to pass it through the left and the right bar of that drop light. So that's the friction hitch. I'm not going to close it in a bend yet because I want to show you the variations. So let's take that and redo the end of it. Let's back this out and let's show you what happens if I take this line, instead of a 4-1, what if I do a 4-2? 4, I'm going to grab 2 strands of that upper hitch, upper segment. So that's 4-2, and then the bottom's the same. This is a variant. This is the 4-2-3 variant, and I love this variant. This variant has some properties. 2 very favorable properties. Well, I mean, it depends on your application, but I do like them. So the one property is that it's easier to break under load. So you've climbed up in a tree, whether you're on a single or a double system, and then you want to transfer into rappel mode with your body weight on the system and your rappel device further down in the system. With very minimal force can break this friction hitch and transfer my weight to my rappel device. And the second point is that the load which can be absorbed by the handle, we could consider that a failure mode, that if you got your handle here, and this being a left-handed ascender hitch, if you were to tug on that, I mean, it's possible, if not easy with the right amount of force, to cause this thing to come apart. I won't be able to do it. But that finish, the 4-2 option, makes it more stable and less prone to being pulled apart by the handle. The only downside is that it's a little bit more work to dress and set because of the fact that that descending line is going through more strands and has more friction. Getting it set properly the very first time, see how it's moving? I mean, it's really no big deal, but I would just encourage everybody to make sure you've set it properly. But this constitutes the 4-2-3 variant, and is actually my preference lately in my climbs. The 4-1 works great, but and let's just show you one more thing. When I started this hitch, I actually was using a 4-0 variant. I just took this line coming off the top here, and I simply put it through. I don't really like this, didn't find it performed as well, but this would be considered a 4-0-3 variant. I mean, it does hold. You can try that, climb on that, and this is the easiest to set and dress. So there's a 4-0 variant. I showed you the 4-2, and now I'd like to show you going the other direction. What happens if I try a 100% ratio? What happens here? We have 7mm sterling accessory cord with 7mm sterling accessory cord, a different color. 100% ratio, like we would tie a Blake's hitch, for example. My toggle goes here, my handle, excuse me. But once we get in these diameters and extreme loads, a failure mode emerges where we can capsize the hitch. I can't do it in climbs with those other diameters. But once you get into these ratios, and of course I wouldn't climb on accessory cord, but I'm going to tug on this, and I think I'll be able to get this bite to capsize. I'll get this to fold up like that. And if not, I'll have to simulate it. What happens is, with enough load, we can get the hitch in this state. So I apologize if I went out of view there, but the idea is that this becomes a non-usable friction hitch. You didn't slide, you didn't go anywhere, but you're also kind of stuck there. And so how can we remedy that? And we can remedy that with, I can get this out of the way. So here I have fashioned that same friction hitch, but it's just not finished yet. You'll recall that this was the working end of the rope that I brought down. So 4-1-3 variant. So taking what was the standing end of the rope and turning it into the working end, I am going to go in that same chirality around the back, and it'll go over that drop bite and exit. That variant we'll call the 4-1-4 variant, binds this drop bite and it prevents it from capsizing in that fashion. You can put an extreme load on this, and I have, and it does not capsize. Now, so why don't I use this for climbing? Well, it's a little harder to move. It binds up a little bit more friction there. It's a little harder to move. And so I don't really like this option for my regular climbing, but I want to recognize that someone might want to use a 100% ratio. And if you did, I would recommend this variant and recognize it'll be a little harder to move. And the handle still can be put in. I can put it in like that. And I won't take the time to put the bend on the end. Okay, so in terms of failure modes, let's just go over them. Let's say the hitch isn't grabbing properly. If it's not grabbing properly, that's probably because there's too much slack in it. And so we're going to dress it. We're going to pull on that descending line. And if it still doesn't hold, we'd add additional coils and turn our 4 into a 5. Let's say that it just jams. It's too jammed up. Well, then we have to add slack back into that, and You know, I find that it doesn't jam up because I'm not afraid of having the right amount of play in there. But if you were to rappel on it, you know, during rappel, if you had it tuned optimally and then you're rappelling, you know, some of that slack might come out. And so if you do rappel on it, you might have to just reset it at the bottom and make sure you reset it for each climb. Let's say you just can't break it under load. Okay, well, there's a couple of options there. Some are mechanical in nature. The way that you're actually climbing, you put a little load with your feet on the rope. But if you can't break it under load, well, then you definitely, especially if you're using the 4-1-3 variant, that's where you might want to go to, the 4-2-3 variant, and getting that 2 in the middle instead of 1. And if it comes apart, and I don't know if I'll be able to actually simulate this, but if you yank on this enough, you can get that to come apart a bit. And again, I'm exaggerating. I've never been able to do that in a climb, but that's where the 4-2-3 variant is better than the 4-1 variant. Okay, all right. So that, and this was the 0 I was demonstrating on because it's even easier to spill. So that basically summarizes it. Sorry for all the words, but we had a lot to say. So, you know, subject to your comments and discussion, I will do some detailed videos on exactly how to tie each variant and get on with some climbing. Thank you.